A 4-meter cantilever beam supports a uniform load of 25 kilonewtons per meter throughout its length. The beam deflects 20 millimeters at the free end, given a flexural rigidity that is equal to 50,000 kilonewton meters squared. We are tasked to find the force at the free end that is required to eliminate the deflection at the end in kilonewtons, and the force at the midspan required to reduce the deflection at the free end by 16 millimeters in kilonewtons, and the force at the free end required to reduce the deflection at that end to 8 millimeters in kilonewtons. For the first problem, we are given a cantilever beam that has a length of 4 meters, and due to the uniform load, this beam here deflects at a value equal to 20 millimeters or 0.02 meters. This is due to the uniform load applied on top of this cantilever beam that has a value of 25 kilonewton per meter. And to eliminate the deflection, we have a point load, let's call this P, that will induce a deflection that is equal to 0.02 meters to eliminate the overall deflection of this beam. So by equating the deflection of the beam to the formula of the deflection induced by a point load on the cantilever beam at the free end, that is given by the formula PL cubed over 3I. We can solve for P, knowing that our deflection here is 0.02 meters and our length here is 4 meters. And given the flexural rigidity that is equal to 50,000 kilonewton meters squared. Now we can solve for P, that is equal to 46.875 kilonewtons, and that is letter A. For the second problem, to solve for the force at midspan required to reduce the deflection at the free end by 0.16 meters, we will use beam formula, where the load is found at the midspan of the cantilever beam, that is given by the formula 5 PL cubed over 48 EI equal to the difference between the total deflection, that was 0.020 meters, and the final deflection of 0.016, that is equal to 0.004 meters. So we're given the length of the beam, that is 4 meters, and the flexural rigidity, that is EI equal to 50,000. Solving for P, we get a value equal to 30 kilonewtons, and that is letter B. To calculate the force at the free end required to reduce the overall deflection of 0.02 meters at the free end to 0.008 meters or 8 millimeters in kilonewton, we will utilize the beam formula given a concentrated load at the free end, that is P. This is given by the formula PL cubed over 3EI for the cantilever beam. We equate this by the deflection induced by the load that would help reduce the deflection at the free end to 8 millimeters or 0.008 meters. So plugging in the known values, we have 4 meters and EI, that is 50,000, equal to 0.008 meters. Solving for P, we have the value for P, that is 18.75 kilonewtons, and that is letter B. And these are our final answers.